We're very excited that MetPy 1.0 is now released. This week I'm going to show you the one thing that you'll likely have to do to several of your scripts to update to 1.0 without any problems. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. We're really excited that MetPy 1.0 is now out. It's been a while in coming and we've had release candidates out for some time. But now it is indeed out there and you can install it through pip or CondaForge, the normal channels. This week I want to show you the thing that you'll probably run into most when you do this upgrade to 1.0 and a very simple change that you'll need to make to some of your scripts. In later MetPy Mondays, we'll look at some of the other new features of 1.0 as well. The main change that you'll run into is some of the arguments to functions have been changed a little bit. This was for consistency throughout the library. In some cases, it involves the name of the function arguments, and in some cases, it involves the order that they are expected in. It's a lot easier to just show a couple of examples rather than to try to explain it. So let's fire up a notebook and write a little bit of code. I'm going to go ahead and import metpy.calc as mpcalc. And then from metpy.units, we're going to import the unit registry units. So first, let's look at the when component calculation, one of the first features ever in MetPy, and one that I use quite a bit. Using my tab completion there to save myself some typing. If we look at the doc string, it's going to take speed and when direction. So for example, I'm going to provide 10 meters per second speed, and then for direction, 45 degrees. And that works great. We get minus 7.07 meters per second for both the U and V components. This is likely how you use the when components function in all of your scripts. And as you can see, it works with MetPy 1.0. So you're probably not going to have any changes. That's because you're probably using these as positional arguments. So the speed first, and then the direction in degrees second. If you were actually passing the variable name, though, you might have to make a minor change. And that's because it would have looked like this. You would have had speed equal to 10 meters per second. And then you would have had when direction equal to 45 degrees. As you see, now we have an issue. Missing a required argument when underscore direction. That's because wdir has been replaced with wind direction. It's a much more descriptive name, and again, it makes things consistent across the library. So that is probably the most common thing that you'll run into with these positional arguments if you were using the actual name of the argument. This is definitely clearer and better practice to have these longer, more descriptive names, and it's a very simple change with just find and replace. Okay, so what about functions where we had keyword arguments that we had to specify? The most common change that you'll probably run into is the change of heights. So let's take a look with an example of the mean pressure weighted function. The mean pressure weighted function is a way to take a mean or an average of some value over pressure instead of height space. But you could also optionally specify heights. This would be very useful for, say, taking a sounding and finding the average temperature or dew point within some layer of interest. So from mpcalc, we're going to use mean pressure weighted. Again, tab completion there helping me out. You can see that we have a positional argument of pressure. Then we can pass some arbitrary variable. It could be temperature, dew point, or variables even. And after those other positional arguments that are denoted by that star args, there are keyword arguments: height, bottom, and depth. It's especially important since there could be an arbitrary number of args that these are keyword, hence why the docstring and the function signature looks like it does. So let's go ahead and use this function. I'm just going to make up some values here of 1,900 and 800 units hectopascal for my pressure. And then for the temperatures, I'm going to use 290, 288, and 286 units dot Kelvin. Remember, it's Kelvin. If it's Celsius, it would be deg C, Fahrenheit, deg F. And then finally, heights, but they are going to be a keyword argument. If you're using this function in your pre-1.0 release, this is how it would look. Let's say 10 and 1,000 and 2,000 times units dot meters. Again, the values don't really matter here, but it's not going to work, and it is for a very similar reason. Unexpected keyword argument, heights. That is because it has been changed to height everywhere in the library. Again, a cleaner and more universally accepted name that's going to be consistent across all of our functions. If you want to see everything that's changed, you can go to the MetPy 1.0 docs. You'll notice this looks a lot different. The MetPy team put in a lot of work to make this consistent with all of the other Unidata products and make it even easier to navigate. In fact, there's even a 1.0 upgrade guide linked at the top of the page. After some explanation about what a 1.0 release means, there's a link to the API changes in 1.0. Here are the positional arguments that we just talked about, followed by a list of all the functions that were affected, showing the old and the new arguments. So you can go through this if you're having a problem, or just look at the doc strings if you're having a problem. But again, these are all find replace type issues. And here's another example: dry static energy, heights goes to height. Similarly for keyword only arguments, mean pressure weighted, which we talked about, the old and the new. And there's just a few of those. There are a few new keyword only arguments, some reordering of parameters, which we'll talk about in the future, though it's been now universalized among all of our functions, pressure being the first coordinate, if it's involved in that calculation. And some work on the grids, which again we'll talk about in future MetPy Mondays. But for now, I encourage you to create a new environment, install MetPy 1.0 in that environment, and just try your scripts. Many of them will probably work with no changes. A few of them might require minor find replaces. Then we can look at some of the other advantages of 1.0 that aren't breaking, but that can greatly reduce the amount of code that you need to write. There are a lot of great things going on with Xarray that mean you can delete large blocks of code because it can all be taken care of for you, which is our goal at the end of the day. Because if you're a scientist, your goal isn't to write code, it's to get results from that code, not to write more code to maintain. So anytime that you can delete more lines of code than you've written, it's a good day. I hope that you found this useful and that you enjoy MetPy 1.0. We're really excited that it's out there and excited to hear your feedback. Join me next week as we continue our exploration of the functionality in 1.0, and I'll see you on next week's MetPy Monday.